One option we always have when we're doing these is we can just change the square root of 5 into what it actually is. And the square root of 5 is 2.24, essentially. It's a round up number. And what we do is we set up two equations here. One of them is the left side involving the middle, and one of them is the right side involving the middle. And then we just solve these out independently. So we have, you actually can solve these in rows. Let's do that. So it's minus 2.44. I make these like little alleyways here. So what we're going to do is we're going to add 2.24, excuse me, to both sides. So what we get here on the left is 1.24. And on the other side, we will have 6.24. So we need the x value to be greater than 1.24, so that excludes these. It involves the 1, and we need it to be less than 6, which gives us our value of g. We can also set this up and do this with a calculator. Here's how this would look. So the way I'm going to solve this is I'm going to take my middle expression here and see when it is greater than -1 and also less than 4. So I go to y equals and I type in exactly what I see, x minus the square root of 5. And then I'm just going to refer to my table and see when it meets the criteria. So when is it greater than -1? Well, we can see at 1, it is lower than -1, and at 2, it is greater than -1. So the first value that we see where it is greater than would be the 2. So that takes us down to G and H on this. And then we also want to see where this equation is less than 4. So it gets greater than 4 at 7, and it's less than 4 at 6, which means our correct answer would be the values between 2 and 6. This example, I don't have any tricks on this one, we just solve. What it says, the wind blows against the flat surface, exerts a maximum force of this equation. K being a constant value, S being the surface area, V being the wind's velocity. If a 40 mile per hour wind, that would be our V value, can exert 50 pounds of energy, or force, excuse me, that's our equal to, in 1 square foot. So we don't know what the K value is, and we know that the S value, capital S, is just a 1. So what we're going to do is get a K value from the first one, and we're going to transfer it over to the other side. So obviously 1 times K is K. 40 squared is 1600. So what we end up with is 1600 K equals 50. And then we're going to divide 50 by that 1600. And what we get is 1 over 32. So the constant value is 1 over 32. So we're going to immediately take this 1 over 32 and create a second equation in which we are missing the maximum force. So we'll just call it F. We know the constant value is 132, and it says in this one that it has a surface area of 2 square feet, so that would be our value of 2. And then it tells us it's an 80 mile per hour wind, so it's going to be 80 squared. So we put all of this into our calculator. When we put that all into our calculator, we get a value of 400, which is our answer D. As we look at this one, what we're supposed to be doing is finding the volume of this unique, shape here. So I'm going to break it into two rectangles. One is a 4 by 10 rectangle, which would have an area of 40. And this one is not a 20 by 4 because remember I just cut off a piece of 4. So this is going to be 16 by 4. So we will put all of this into our calculator. This is 64. So our total area is 40 plus 64, which is 104. But these are being measured in feet. So it's 104 feet. It tells us the concrete, though, is laid at a depth of 4 inches. So it is length times width times height for volume. But in this case, the volume is comparing feet to inches. So what I'm going to have to do is write 4 inches in terms of feet. So that would be 4 of 12 as far as we're considering in feet because it's 4 inches of 12. So when we put this into our calculator, we get 34 and 2/3 essentially. It's 0.6 repeated. So this is our volume in feet. But what it tells us is that the concrete mix makes up to 0.6 cubic feet. So we want to find out how much we need to use, so we divide both sides by 0.6. And the amount of bags we're going to need is actually 57.7 repeated. So 57 bags is not enough. We will have to take the 58th bag. So in this one, I'm going to create a bunch of trig formulas. There's the information that's describing what's happening, but what I'm going to do is first find out what this radius is. Well, we only have this angle. We do know the other angle, by the way. It's 70 because we have a right triangle with one angle. So from 20, this is the opposite side, and the adjacent side are the ones that we have. So the opposite adjacent is tangent. So make sure in your calculator that you are set equal to degrees. But tangent of a 20-degree angle is going to be the opposite side over the adjacent side. So in order to get x by itself, we're going to multiply times 12 to both sides. So I'm going to put in my calculator 12 tan 20. And again, if you're in radians, you're going to get a wrong answer here. So what we learn is that x is equal to, it's approximately 4.4. So the radius of our circle is approximately 4.4. And by the way, what we're looking for is the length of BP. So we got to do a few steps in order to get ourselves there. Well, now we need to know what the length of this side is from here to here, because we know this radius, if it's a radius of 4.4 here, then it's a radius of 4.4 here as well. So I'm going to use another trig ratio. Well, on this trig ratio, I need the hypotenuse, so I can use either of the two sides, but I'd prefer to use the 12. So from this angle, we need the hypotenuse, and we're going to use 12, which is the adjacent side. So the trig ratio we're going to use for the second one is cosine of the 20-degree angle equals the adjacent side, 12, over the hypotenuse, which we don't know yet. So I'm going to multiply times h on both sides to free up the, we have to move the h in order to actually get to it. So we have h equals cos 20 equal to 12. And to get the hypotenuse by itself, I have to divide by cos 20. So I'm going to be doing 12 divided by cos of 20. And what I learned is the hypotenuse has a measure of 12.77, essentially. All right, so we know from here to here is 12.77. And from here to here is 4.4. So we're going to take our 12.77 and subtract 4.4. And when we do that, we get 8.37, which rounds up to our value for E. This is also a question you need to consider time management on this. I worked through this one pretty quickly. It still took me about 3 minutes. If you're working seamlessly, it may be worth the time. Don't sit here and dwell and just hang on to these questions so much. Make a very educated guess on these. Don't waste a lot of time and then guess, though. Either, as the saying goes, cut line and move on, or give it your best shot. On this question, it says we have an average of 10 scores, which is X, and the highest and lowest score are removed from the 10 for an average of Y. Which of the following is the expression for the average of the highest and lowest score? The best way to do this one is just to go back to their raw scores. Remember, the average is adding up all the numbers, the sum of the numbers, divided by the total number. So in order to move the X back to its sum, I'm going to multiply times 10 because I divided by 10. And the Y value only divided by 8. So to get it back to its original score, I only have to multiply times 8. So if I want to see how much more was in the 10 than the 8, all I have to do is subtract the raw score of the 10 by the raw score of the 8. This will give me how much more those other two were. And if I'm trying to find the average of those two scores, I then have to divide by 2. This is another one where time management needs to come into consideration. Don't bang your head on the wall trying to get these. Look for a pattern within the answers, kind of like the fact that I see an 8xy in every single one of these, which means it's probably in the answer. I see a divided by 2 in 3 of the 5 answers. And the subtraction and adding are in both. So, I mean, really, if you're looking at pattern recognition, we're probably going to choose H or J, and I cannot think of a reason to pick one over the other. But it's still a 50-50 chance, which is much better than a blind guess. So in this example, what I'm going to do is use the gather and graph method that I like to use. So I'm going to move the 9x over to join the 27, and that way I could just see where they cross the x-axis. So I like to just hit, instead of an equal sign, I'm going to hit subtracted by, and I don't need these parentheses, but I just want to get in the habit of plugging parentheses here. And then we put everything on the other side. So this is the gathering portion of our equation. We've gathered everything to one side. So now we have it set equal to 0, which means anywhere it crosses the x-axis is a solution. So I'm going to look at the table and see if any of these values stick out. And there it is, 2. And 2 only takes place in one of the answers, and that is E. But I'm going to just show you another skill, and that's checking the value 4/3. If I hit second trace, the first option is value. This allows you to look up which value I'm interested in down in the bottom, and I'm interested in 4 divided by 3 4/3. When I hit enter, you can see that this has a value of 0, which is my other solution. All right, so this first two sentences tells us that a dice has 6 sides. So let's just get to the question. What is the probability the sum of the two numbers on the face landing up will be less than 6? So there are actually 6 faces on a dice, and there's 6 on the second dice. So the total number of outcomes we can have is 36. Now, the ones that can add up to a number less than 6. Well, let's just go through the one dice. will be less than 6. So we could have a 1 and a 4, a 1 and a 3, a 1 and a 2, and a 1 and a 1. Now on the other on that same dice, we could have a 2 and a 3, a 2 and a 2, and a 2 and a 1. And then on the other dice, we could still have a 3 and a 2. And that is all we can have. I'm sorry, we have one more outcome. We could roll a dice that had a 4 and a 1. And I believe this takes care of all of the different ways we could have this. I'm going to make sure they all pair out. There's this. I don't have a 3-1, so I am missing one. We could also roll a 3-1. And there should be a descending order on this. I knew something looked funny. That's what it was. 3 and 1, 3-2, 2-3, 2-2. Only one way to run 2-2, and only one way to run 1. So what we have is 4 outcomes, 3 outcomes, 2 outcomes, and 1. So we have a total of 10 outcomes out of the 36. These are both even numbers, so this would break down to 5/18. So this example says at 2 p.m., Louisa leaves Kansas City in her car traveling I-70 towards St. Louis at an average speed of 68 miles per hour. At precisely the same time, Antonio leaves St. Louis in his car traveling west on I-70 towards Kansas City at an average rate of 57 miles per hour. So these two are in opposite cities driving towards one another. It says the distance that they're between St. Louis and Kansas City is 240 miles. So together they're going to travel 240 miles. Now, Louisa's distance is going to be rate times time. Well, we don't know how long she's going to travel, so we will call it an X. And we don't know how long Antonio's going to travel, but we know they're both going to travel the same amount of time. So they're both going to be X. Now, their distances are going towards each other, so they're assisting each other in their travels. So we are going to put a plus sign here because together they're going to go 240 miles. Now, when we add up their rates, because we have a like term here, we get down to this. This is 125x equals 240. We're going to divide by 125x to see how much time they've traveled. And we're going to get a really weird number here because we have x equal to 1.92. Well, we're talking about hours. So we know they're going to travel 1 full hour, which would take them to 3 o'clock because they left at 2. So what we need to do is find out what is 92%, 0.92 of an hour. So what we do is we multiply that times an hour, because we're talking about minutes here. So 92% of an hour is 55 minutes, 55.2 technically. So what they've traveled is an hour and 55 minutes. So an hour and 55 minutes more than 2 o'clock is 3:55. So in this one it says we have 10 points on a plane. There are no 3 points that are collinear. There are 10 points on our plane. It says taking 2 points at a time. How many distinct lines can we have here? So we're 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what you're going to see is as we connect these dots, every time we connect one, we're going to have one less combination we can have. So I'm going to just focus on this dot for right now. There's 1, 2, 3, 4, 5, 6, 7, 8, and 9 unique lines. Now I move over to this one right here. Well, we've already drawn that line. So we have 9 for that one, sorry. So we have 1, 2, 3, 4, 5, 6, 7, 8 lines that involve this. And we'll just do one more because you're going to notice the pattern. We've already drawn the lines from red to green to this. So we have 1, 2, 3, 4, 5, 6, 7 unique lines to this. So what we have here is every time we go down, we're going to descend by 1. So we will have next 6 unique lines, 5, 4, 3, 2, and then finally 1. So if we're trying to decide how many of these we have, we add up all of these points individually. And when we do that, we get 45. So on this example, we can actually put this straight into our calculator. So I'm going to go to y equals and type in this equation that I see here with the exclamation points. These are called factorials. But I'm going to set up my fraction mode, and I'm going to put in x plus 1. Factorial. This is under math, and if you scroll over to probability, it is this option number 4. And then I'm going to hit 6 factorial. And my denominator is x factorial, 3 factorial. And what a factorial is it's multiplication of the descending numbers. So 3 factorial is 3 times 3 times 2 times 1. So we type all of this in, and this is what our equation is. And I'm going to see which one of these multiple choice answers has a matching table. I'm going to go ahead and look at the table, see if it looks linear or what it looks like. It's obviously not 120 or 2 because those are constant values. So I'm marking those off. So let's see if it's the option A. So I type in 120. Times x plus 1. And then I'm going to compare the two tables. You can see those two tables are identical, which means the answer is A. So I'm creating a triangle here. This is probably going to be one many of you are going to guess on, and it's probably a good option here. So I'm creating this triangle. 1 plus 0 equals 1, and then we set 1s across the edge here. 2 plus 1 is 3, 2 plus 1 is 3, and then 1 plus 0 is 1. And then we would have 1 here. This would be 4. 3 plus 3 would be 6. 3 plus 1 would be 4. And then we would have our edge 1 here. So what this is the powers as we walk through perfect expanded polynomials like this. This is level first power 1, power 2, power 3, and in the fourth power, the way this reads, this would be x to the fourth, this would be x to the third, this would be the x squared, this would be the x, and this would be the constant value. And it asked me for the x squared value, so this would be 6. Again, hopefully you recall that whenever you're taking the test, but don't sit there and dwell on this one too long. What they really want you to do is they want you to set up x plus 1 times itself 4 times. This is a very exhausting problem. They're really hoping that somebody knows this, and they're rewarding them for that, and they're burning your time on this. So this is one of those I don't think it's worth sacrificing 5 or 6 minutes to do this one appropriately, but this is one way we could get fast forwarded through this. Okay, this is a question where many of you are going to skip it. Please stop skipping stuff. We know about triangles. We know that the larger the angle is, the larger the opposite side. We know the two smaller sides have to be larger than the largest side. And we see these weird answers here in the instructions. I even cut off a part of the instructions here because they were worthless to us. Because they're writing the equations for us. But here's what we know. This is 20 degrees, this is 70 degrees, which these two are a linear pair, so this is 110 degrees. So this is clearly the largest angle, which means this is the largest side. And by the way, it's the largest side by a good bit if we're talking about 110 degrees. So some of you are probably wondering what I'm talking about on this. So let's do this. Let's take all of these 5 values and just put them into our calculator and see what their values are. I'm going to pause it and come back with the decimal answers for all of these numbers. Actually, I'm going to just go ahead and put these in so we can see how much time this takes and see if it's worth a correct answer. So the first one becomes 63.3. The second one, if I hit second entry, it's going to pull up my data because the only thing that's different here is that it's sine of 70 over 60. So that's a real quick answer. Type that in. This is 68.689. So the next one, I'm hitting second entry again. It's 110 degrees as opposed to 70. Type this in, and I get the exact same number. Exactly the same. Here's the thing about the ACT. You cannot have 2 correct answers. So when these 2 answers match, it actually works to our favor. They both cannot be an answer because they're not distinct from one another. So that is automatically a wrong answer. I'm going to type in the next part as well. 60 squared plus 25 squared minus 2 times 60 times 25, and then cos 70. And again, I'm not going to have to type this whole thing again next time because you can see there's only a slight difference. So this one says that it is 56 degrees, 56.6 to be exact. And then I go to the last one. I just hit second entry, pulls up all that data. All I've got to do is type in 110 and for this. So now we are at 72.46. Now let's take a look at these answers. First of all, 56 is smaller than this side. Well, we just established that 110 is the largest angle, so we're looking for the largest side. So this one is down to the largest side, or is out for the largest side. So by doing nothing other than putting this stuff in our calculator, we're down to 50-50. And we can make a really good guess on this as well. 63.3 is just a little bit bigger than this. But if you look at these angles, this is 110 degrees. This angle right here, and B is actually the angle we're interested in, is considerably smaller than 110 degrees. So this side is going to be considerably smaller. So really the best guess on this is the 72.46. And this is actually a correct answer. We did no trig on this. A lot of times if you'll just compare your data, like leaving radicals as radicals is a poor choice. Leaving sine, cosine, and tangent as sine, cosine, it's a poor choice. Turn them into decimals so you can make an educated guess. All right, good luck.